Time, the one thing we believed was constant, has just been challenged. In the endless dark, where light itself takes more than 13 billion years to arrive, the James Webb Space Telescope has seen something that shouldn't exist. 300 galaxies, blazing quietly at a moment when the universe had barely learned how to breathe. They were never meant to be there. There wasn't enough time for stars to form. There wasn't enough matter to gather into spirals of light. No law of physics allows what Webb just saw, and yet, there they are, red, radiant, and impossibly ancient. In each tiny crimson dot, hidden in the deep field, lies a silent rebellion against everything we thought we understood about creation. Each galaxy, a cathedral of light that shouldn't have been built yet. If they truly existed just 500 million years after the Big Bang, then the universe has been breaking its own rules from the very beginning. Imagine a newborn child speaking in full sentences moments after birth. That's what Webb is witnessing. Cosmic infants that grew into giants before the universe itself was ready. They shouldn't exist, but they do. And their existence tears at the fabric of time itself. Because if these galaxies are real, it means something deeper than physics has changed. It means we have underestimated the universe, not in size or power, but in imagination. And perhaps the most terrifying truth of all is not what James Webb has found, but the possibility that we've believed the universe was simple for far too long. Chapter 1. The Impossible. Dawn. In the beginning, there was no light, no stars, no warmth, only the faint echo of creation, rippling outward through a darkness so complete that even time seemed hesitant to move. The universe had just been born, an infant wrapped in silence, expanding faster than comprehension, filled with invisible matter and the ghostly afterglow of the Big Bang. It was not yet a place, but a promise, a blank canvas of potential. For hundreds of millions of years, nothing stirred. The first atoms drifted through a sea of cooling radiation, too hot to form, too scattered to shine. The cosmos was asleep, breathing quietly, waiting for its own awakening. And then, something impossible happened. Out of the darkness, the first light broke through, faint, red, trembling, like a heartbeat in the void. It wasn't supposed to be there. Not yet. Not so soon. But there it was, spreading across the black like a whisper that refused to die. That was the dawn, the impossible dawn, when creation itself began to speak. Billions of years later, we built a machine to find that moment again. The James Webb Space Telescope, a golden eye orbiting beyond the shadow of Earth, made of 18 hexagonal mirrors, each one aligned with atomic precision. It was not just a telescope. It was the face of humanity turned toward the beginning of time. Its purpose was simple and sacred: to see the first light, to catch the echoes of our own origin. When Webb opened its mirrors to the deep sky, it looked farther than any human instrument had ever dared, beyond the galaxies we knew, beyond the stars we named, beyond the edges of imagination. And in that infinite stillness, it saw them. 300 galaxies, blazing red against the black, their light stretched by 13 billion years of distance. They were enormous, vast cities of stars burning at a time when the universe should still have been dark. It was like watching a newborn speak the language of the stars. Each one glowed like a torch, a defiance against emptiness. Their light was soft, yet unyielding, the color of memory, the sound of something eternal remembering itself. The data came in quietly at first, just numbers, just signals. But the longer the scientists looked, the less sense it made. Those galaxies were too massive, too old, too structured. They weren't supposed to exist, not in that age, not under those conditions. The universe was too young, too hot, too chaotic to build such things. And yet, it had. The discovery spread through the world like a shiver. Every observatory, every lab, every sleepless researcher felt the same realization rise within them. Something fundamental was wrong. Or perhaps something deeper was right, but beyond what we understood. Because if this light was real, and it was, then our picture of creation had cracks. Our laws had limits. The universe had moved faster, thought faster, built faster than we ever imagined. It had skipped the rules we thought were unbreakable. And that left us with one haunting question. If this could happen, what else could be wrong with physics? What other certainties might collapse when the next light arrives? The James Webb Space Telescope didn't just show us galaxies. It showed us the edge of understanding and dared us to step beyond it. Beyond. Chapter 2. What Webb Saw. Far beyond the blue curve of Earth, the James Webb Space Telescope drifts in silence. A golden machine suspended in darkness, its 18 hexagonal mirrors unfold like a mechanical flower, each petal polished to catch the faintest breath of light. Sunlight never touches it. It lives in shadow, 1 million miles from home, cooled to near absolute zero. It doesn't see in color, it sees in time. Webb's vision is infrared, the kind of light that reveals what the human eye cannot. When light travels for billions of years, space stretches it, turning blue into red, warmth into memory. That's what Webb captures, not the light of now, but the stretched echoes of the beginning. To understand what that means, think of a siren passing on a city street. As it moves away, the pitch drops, the sound stretches. That's the Doppler effect. Now imagine the same thing with light. The farther something moves, the redder its color becomes, redshift. The universe itself is expanding. And as it does, it drags light with it, stretching it thinner, colder, older. The deeper Webb looks, the more ancient the light becomes. It's not seeing distance. It's seeing time itself infinity backward. When Webb first turned its golden eyes toward a patch of sky so small it could be covered by a grain of sand held at arm's length, no one expected much. It was chosen precisely because it was empty. No known stars, no galaxies, just blackness. But as the data streamed in, the void began to bloom. Tiny red specks appeared, one after another, until the image looked like a tapestry of embers burning in the dark. Every one of those specks was a galaxy, vast, ancient, and impossibly far away. Each one contained billions of stars. Each one existed when the universe was only 500 million years old. 13 billion years of distance compressed into a single frame of light. The scientists stared, stunned. They'd seen deep field images before. Hubble's portraits of the young universe, filled with small, irregular galaxies barely forming. But Webb's view was different, sharper, deeper, stranger. Hubble had shown us infants. Webb was showing us civilizations, fully grown cities of stars, spiral arms, glowing hearts, clusters of suns, orbiting invisible centers of gravity. It wasn't supposed to be possible. At that age, galaxies should have been fragile things, small, shapeless clouds of gas still learning to form stars. But Webb saw maturity where there should have been infancy. The image was quiet, yet defiant. The red of its galaxies wasn't just a color, it was time made visible, history painted across the black. Each photon that struck Webb's mirror began its journey before our solar system existed. Before the Earth cooled. Before atoms in your body had ever been forged. The telescope wasn't just looking outward, it was looking backward, tracing the light of creation itself. The numbers told a story almost too vast to grasp. The faintest galaxy in Webb's field had a redshift of more than 10 meaning its light began its journey when the universe was less than 4% of its current age. To put that in human terms, imagine photographing an embryo and finding it already walking. The early universe should have been dark, filled only with hydrogen fog. Gravity shouldn't have had time to sculpt it into stars. Yet Webb was staring at a sky full of them, organized, massive, luminous. Each one a contradiction wrapped in beauty. The scientists recalibrated. They checked the data again and again. The numbers refused to change. The light refused to lie. The impossible was real. Across monitors and labs around the world, people fell silent. In that silence was something profound. The feeling that we had seen too far, and what we found was staring back. The telescope wasn't showing us new objects. It was showing us the limits of what we believe. The red glow on those screens wasn't just ancient light. It was the universe whispering a challenge. You've misunderstood me. And somewhere in that whisper, a realization began to take shape. Maybe the universe wasn't patient. Maybe it never was. Maybe it built its first galaxies not slowly, but all at once. A burst of creation of ours that even time struggled to keep up. The data from Webb didn't just expand our view, it fractured it. Every pixel was a question, every red point a contradiction. The universe had revealed its secrets and rewritten its own rules in the same breath. This wasn't supposed to be possible, yet here they are. Chapter 3. The Rules of Creation. Before chaos learned restraint, the universe followed no rhythm. It expanded without pause, a pulse without pattern, until gravity began to whisper instructions. From that whisper, order emerged, not suddenly, not violently, but through a slow and deliberate choreography that we would one day call physics. These were the first rules of creation, invisible, mathematical, patient. Long before the first stars burned, the universe was already learning how to build. The architects of that structure were unseen. Dark energy stretched the fabric of space, while dark matter provided the framework. A network of hidden filaments threading the cosmos like nerves through a living body. On that invisible skeleton, ordinary matter began to gather. Hydrogen, helium, the simplest of elements, drifting, cooling, obeying gravity's quiet pull. Where enough of it condensed, heat and pressure rose until atoms fused. The first stars flickered to life, and from them came everything else. It was a process of balance, expansion and collapse, attraction and resistance, always seeking symmetry. Galaxies grew from these early patterns, merging, rotating, finding harmony across billions of years. To us, it seemed natural, inevitable. The universe was an engineer, meticulous and unhurried. Its equations were consistent, its behavior predictable. Every observation confirmed it. The cosmic microwave background, the faint relic of the Big Bang, matched our models with eerie precision. The distribution of galaxies across the sky followed the same geometry our equations foretold. Even the age of the universe, the rate of its expansion, the way stars clustered, all of it fit the grand architecture we called the Lambda CDM model. Lambda, for the pressure that pushes everything apart. Cold, dark matter, for the invisible scaffolding that keeps it from flying to pieces. Together they explained almost everything. Almost. In this framework, galaxies were expected to evolve gradually. Gravity gathered matter, dark and visible alike. Small clumps collided, merged, and grew larger, layer upon layer, like coral building a reef. Each generation of stars enriched the next with heavier elements, making the universe more complex with every cycle. It was a cosmic ecosystem, self-sustaining and methodical. We thought of it as perfect, stable, eternal, like a forest that grows in seasons we could predict. But perfection breeds expectation, and expectation invites surprise. Because when the James Webb Space Telescope peered deeper than any instrument before, it found that the forest was already ancient, while the soil was still warm. Massive, mature galaxies appeared where theory promised only seeds. Their symmetry, their size, their brightness, all far beyond what the clock of creation should have allowed. For decades, we had trusted the slow rhythm of formation. But what Webb saw suggested that, in the beginning, time itself might have moved differently. The early universe may not have been a patient builder at all. It may have been a composer in haste, improvising structure before the melody of physics had settled. And perhaps that is the deeper truth, that the laws of nature were not commandments delivered from the start, but habits the universe learned through repetition, like a heart discovering its own beat. Gravity did not know how strong to be. It experimented, adjusting until stars could exist. Matter did not intend to form galaxies, it followed the paths that survived. Physics, in that sense, was evolutionary, born from trial, error, and persistence. The Lambda CDM model describes what remains after that learning. The stable order left behind by a universe that once struggled to understand itself. When we simulate its equations, we are not recreating the act of creation. We are studying its memory. Because those first billions of years were not the result of rules. They were the birth of rules. That distinction changes everything. It means that the cosmos was once wild, capable of invention, driven by an instinct we can measure but not yet explain. Perhaps that instinct is still there, hidden beneath the calm surface of the modern universe. The pulse of experimentation continuing quietly, rewriting the constants, adjusting the symphony one note at a time. When we look at the galaxy's web revealed, we are not seeing the violation of laws. We are seeing the moment the laws themselves were written. The universe, in its infancy, was not following a formula. It was becoming one. And maybe that's why we are drawn to study it, because in its endless search for balance, we recognize something familiar: the desire to make sense of existence, to build order from uncertainty, to learn how to be. Chapter 4: Why These Break the Rules. The data looked innocent at first: dots, numbers, wavelengths, nothing more. But behind those red lights was a contradiction so deep it threatened the foundation of cosmology itself. The galaxy's web uncovered were not faint whispers of creation, they were symphonies already in full performance. Their size rivaled the Milky Way. Their brightness implied billions of stars. And their age, less than 500 million years after the Big Bang, made them impossible. According to the laws we trust, the universe at that time was still chaos, dense, turbulent, unrefined. Hydrogen gas should have been too hot to collapse. Gravity should have been too slow to organize. Yet Webb was showing us finished masterpieces in an age that should have known only sketches. Something was wrong. The first paradox lay in time itself. There simply wasn't enough of it. To grow a galaxy, you need generations of stars. Clouds collapsing, burning, exploding, enriching the next wave with heavier elements. That cycle takes hundreds of millions of years. Yet Webb found galaxies already fully developed when the cosmic clock had barely started ticking. It was as if the universe had skipped the rehearsal and gone straight to the finale. The second paradox was temperature. The early cosmos was still warm, filled with radiation left over from the Big Bang. In that heat, matter should have resisted collapse. Gas clouds should have scattered before forming stars. And yet, the galaxy's web revealed were dense, compact, gravitationally bound. They didn't just exist, they thrived, glowing through the fog like embers in a storm. The third paradox was mass. These galaxies weren't small anomalies. Some carried over 100 billion solar masses, a scale that defies statistical probability. There wasn't supposed to be enough matter gathered in such small regions so early on. For that to happen, gravity would have needed to work 10 times faster, or dark matter to behave differently. Either way, something fundamental in our equations didn't hold. Astronomers ran simulations again and again. None of them could recreate what Webb saw. Every model predicted a slow rise from simplicity to complexity. But reality had jumped ahead. It was like discovering a skyscraper in a desert that had never known a foundation. The deeper we looked, the worse it became. The galaxies weren't rare outliers. They were common. Hundreds of them, each one breaking the same rules. And that made the problem undeniable. This wasn't a third error in observation. It was a systemic failure in understanding. For decades, we've relied on the lambda CDM model to describe how structure grows. A universe where gravity sculpts slowly, where time is generous, where matter obeys. But Webb's findings suggest that in the earliest epoch, something else was in charge. The scaffolding of dark matter might have been denser than we thought. Or maybe dark matter itself wasn't as cold. Maybe it moved faster, clustered quicker, shaping galaxies in ways we can't yet simulate. Some theories even suggest the gravitational constant could have been different then, that the strength of attraction itself evolved over time. If that's true, the cosmos we observe today is not just older. It's fundamentally calmer than the one that came before. The young universe could have been violent, impulsive, eager, an artist in a hurry. But if we accept that, we have to rewrite more than equations. We have to rewrite history. Because these galaxies don't just violate our expectations, they undermine the entire narrative of how reality matured. For generations, cosmology has been the science of patience. Small things combine to form big things. Bottom-up evolution, simple to complex. Webb shattered that simplicity. The evidence now points to a universe capable of top-down creation, where vast systems appeared whole, then fragmented later into the structures we know. That inversion is more than a detail. It means our entire sense of cosmic chronology could be wrong. The past may not be as primitive as we assumed. The deeper we go, the more sophisticated it becomes, like finding cathedrals built before the villages that surround them. Some scientists resisted. They argued it must be a misreading. Perhaps dust made these galaxies look older, or lensing magnified their light. But every reanalysis brought the same answer. They were real. They were ancient. They were enormous, and they were exactly where theory said they couldn't be. Each attempt to explain them away only deepened the riddle. It was as if the universe were teasing us, daring us to admit our ignorance. Every law we had trusted, time, gravity, structure, temperature, was suddenly on trial. The instruments were flawless. The error wasn't in the mirror, it was in the mirror holder. The moment scientists realized that, the excitement turned to quiet disbelief. A few laughed. Some cursed softly. Most just stared, speechless, at the realization that the cosmos had once again moved faster than human reason. We called it a discovery, but it felt like a defeat, the kind that forces evolution. Because science doesn't progress by being right. It progresses by surviving what's wrong. These galaxies weren't supposed to exist, and yet they did. That fact alone was enough to shake an empire of certainty. And perhaps that's the true beauty of it. The universe refuses to be small enough for our comfort. It keeps growing, not just outward, but inward, into the parts of our understanding that we thought were safe. When Webb showed us those impossible lights, it wasn't breaking physics. It was reminding us that physics is still unfinished. Chapter 5. The human moment of discovery. They weren't expecting history that night. Just another round of calibration, another stream of data to sift through before dawn. The control room was quiet. A soft hum of machines, the steady blinking of monitors, the faint rustle of notes. Hao Jingyan sat with her coffee gone cold, scrolling through the latest download from the telescope. At first, she thought it was an error. The red dots were too bright, too sharp, too soon. She rechecked the filters, the wavelengths, the timestamps. The numbers refused to move. "Erica," she whispered, "come look at this." Erica Nelson leaned over her shoulder, eyes narrowing, then widening. "That's not possible." A moment later, Joel Lahar, the systems analyst, joined them. The three of them stared at the data, frozen between disbelief and wonder. On the screen, hundreds of galaxies glowed like embers scattered across eternity. For a long time, no one spoke. In that silence, something shifted. It wasn't just data anymore. It was a message. The realization crept in slowly. They were the first humans to see this, the first to witness the universe breaking its own rules. Jingyan felt her heartbeat slow, then quicken. "If this is real," she said softly, "we're in trouble." Nelson smiled faintly. "Or we're lucky." Lahar only exhaled. "Or both." They laughed, not from joy, but from disbelief. The kind of laugh that happens when the ground beneath you moves and you have no choice but to find balance in midair. Across the world, other scientists saw the same thing. Screens lit up in labs and living rooms. Group chats exploded with screenshots, equations, half-formed theories. One astronomer typed, "Is anyone else seeing this?" Another replied, "No way, it's an artifact." But by morning, everyone knew it wasn't. The impossible had survived every test. There's a moment in every discovery when the human brain reaches its limit, when awe and terror blur into the same sensation. This was that moment. You could feel it through the wires, across time zones and languages, a collective heartbeat, shared by those who had dared to look deep enough. They had set out to confirm what they already believed, and instead found a mirror they couldn't look away from. When Nelson presented the data, her voice trembled. "These galaxies," she said, "shouldn't exist, but they do." Some of her peers argued, some dismissed it outright, but none could ignore it. The images were too clear. The math was too clean. The cosmos had given its answer, and it didn't fit inside our expectations. Discovery is never gentle. It tears away what's comfortable and replaces it with possibility. It demands humility. The night those galaxies appeared on their screens, something inside each of them changed. They had witnessed the universe speaking, and for a heartbeat, they listened. Later, when journalists asked what it felt like, Jingyan said, "It felt like standing on a cliff between knowledge and mystery." Nelson said, "I cried, because it was beautiful and it was wrong." Lihar smiled. "I just kept thinking, maybe this is what curiosity looks like when it wins." Those quotes would circle the world, printed on headlines, tweeted into fragments, turned into documentaries. But the truth of that moment can't be captured in sound bites. It wasn't about fame or history. It was about silence. The kind that follows understanding too big for words. The kind that changes you. When they shut down the monitors at dawn, the room felt different. The air seemed thicker, charged with something ancient and new. The data would travel across the planet, sparking debates, rewriting textbooks, inspiring skepticism and wonder alike. But for the people who saw it first, the memory stayed simple. 3 figures in a dim room, lit by the glow of the impossible. For them, discovery wasn't triumph. It was surrender, the quiet acknowledgement that the universe will always know more than we do. And in that humility, there was grace. Because to be human is to seek, to question, to be wrong beautifully. Chapter 6, The Crisis of Cosmology. When the first papers came out, they didn't sound like alarm bells, they sounded like questions, quiet, careful, surgical. But beneath the calm language of scientific prose was panic. If the Webb data held, then the most successful model in modern cosmology, the one that explained everything from the birth of atoms to the structure of galaxies, might not survive. For nearly half a century, the lambda CDM model had been our cosmic compass. It predicted the distribution of galaxies, the temperature of the cosmic background radiation, the pattern of gravitational waves, even the invisible dance between dark matter and ordinary matter. It worked so perfectly that it became more than a theory. It became faith in equation form. And faith is hardest to question when it seems to work. That's why Webb's discovery hurt. It didn't break a single prediction, it shattered the foundation they were built upon. The assumption that the universe grows from small to large, not large to small. Cosmologists called it the bottom-up model of structure formation. Small ripples in the early cosmos collapse into dwarf galaxies, which merge into larger ones, eventually forming the vast spirals and ellipticals we see today. It's a slow crescendo, chaos organizing itself. Webb's galaxies ignored that score entirely. They appeared fully formed, massive, and bright, long before there should have been enough time for such structure to evolve. If true, that doesn't just bend the model. It unthreads it. Because if galaxies can appear fully mature 500 million years after the Big Bang, then gravity must have been stronger, or matter must have behaved differently, or time itself must have flowed another way. Every constant in the equations of cosmology, HOMLL, becomes suspect. Every simulation becomes an artifact of outdated assumptions. One senior physicist put it bluntly in a late-night email: "If Webb is right, we're wrong about everything." The crisis spread quickly, not through press releases, but through whispers, private Slack channels, preprint archives, closed-door seminars. Some scientists refused to call it a crisis at all, arguing that the data was preliminary, that dust could distort brightness, that redshifts could be misread. But others, quieter, saw the writing on the wall. Because this wasn't one anomaly, it was hundreds. The odds of error repeating that perfectly across so many galaxies were microscopic. The universe was speaking clearly. We just didn't like what it said. Institutions that had spent decades refining simulations suddenly found themselves on defense. Conferences turned tense. Panels that used to discuss future missions now debated whether the framework of cosmology was collapsing in real time. The irony was bitter. The James Webb telescope had been built to confirm the lambda CDM model with unprecedented precision. Instead, it became the instrument that challenged it. Some called it poetic justice, the creation questioning its creator. Others called it betrayal. But science has no room for betrayal, only evidence. The heart of the crisis was this: the lambda CDM model had never been proven in its details. It was an elegant approximation, a scaffolding that fit what we could see. But like all scaffolding, it hides what it builds. The model assumes that dark matter is cold, meaning it moves slowly enough for gravity to gather it efficiently. It assumes dark energy is constant, a steady pressure pushing galaxies apart. It assumes time and gravity behave linearly, even in the most extreme conditions. But what if none of those assumptions were true in the beginning? What if dark matter wasn't cold but restless? What if dark energy fluctuated before stabilizing? What if the rules we call universal were still under construction when the first galaxies formed? Those questions sound heretical, but every revolution in science begins as heresy. The physicists who once swore by Newton's universe had to learn Einstein's. Those who memorized Einstein's now face the possibility that his laws, too, are just a chapter, not the book. That's what Webb's data whispered, not that physics was broken, but that it might be incomplete. And incompleteness terrifies us more than contradiction, because a contradiction you can fight, a mystery you can only live with. As papers multiplied, two camps began to form. On one side, the defenders, cosmologists who believed the lambda CDM model could survive adaptation. On the other, the reformers, younger scientists arguing that it was time to start over. Their debates filled journals and hallways, video calls and midnight coffee shops. Maybe the dark matter is warmer, someone would say. Maybe star formation was more efficient, another countered. Maybe gravity itself is emergent, whispered a theorist from the back, half in jest, half in revelation. Each possibility opened new doors and new doubts. The field wasn't collapsing, it was fracturing, splitting into countless paths, each leading deeper into uncertainty. And yet, in that chaos, there was energy. You could feel it, a return of wonder, the same thrill that must have driven the first astronomers to map the stars with trembling hands. The crisis wasn't the death of cosmology, it was its rebirth. The danger lay not in being wrong, but in being comfortable. As one researcher wrote, the universe doesn't owe us coherence. And maybe that's the point. Maybe coherence is what we bring to it. A temporary illusion of order in a cosmos still learning its own shape. When the dust settles, Webb's discovery will not be remembered as the end of a model, but as the beginning of a new humility. We thought the universe was predictable. It is not. We thought we were near the end of understanding. We are still at the beginning. The galaxies Webb found are not errors in data. They are corrections in perspective. The crisis of cosmology is not a collapse. It's a mirror, showing us what science truly is, not a monument to certainty, but an endless act of listening. Chapter 7. What if physics isn't complete? When theories collapse, imagination takes their place. That is the secret rhythm of progress. Knowledge dies so that curiosity can live. In the silence after Webb's revelations, the world of physics found itself standing on unfamiliar ground. For the first time in decades, the universe no longer behaved like something we could calculate. And that realization, terrifying as it was, carried a strange kind of liberation. What if the laws we know are only local customs? Temporary agreements the cosmos made with itself after the first few billion years? What if, in those early moments, physics was still learning how to speak? The galaxies Webb revealed might not be rebels. They might be fossils from a time when reality followed different rules. Some scientists began to whisper about warm, dark matter, a version of the invisible substance that doesn't drift slowly like cold fog, but moves swiftly, merging and collapsing faster, allowing galaxies to form sooner. In that universe, structure would rise like waves on a stormy sea. Chaotic, yes, but creative. Others imagined modified gravity, where attraction between matter changes subtly over cosmic time. Maybe gravity was stronger in the beginning, allowing the universe to assemble itself quickly before the laws cooled into their current form. A few theorists went further still, suggesting that time itself might have behaved differently, not linear, but elastic, stretching and snapping in ways our equations can't yet describe. Perhaps those galaxies didn't form too early. Perhaps our measurement of early is simply wrong. We define time through the lens of now, but what if then played by another clock? Even Einstein's relativity, once unshakable, might only be a small part of a larger language the cosmos uses to describe itself. That idea used to sound like fantasy. Now it sounds like honesty. Because every century, physics discovers that it was never complete, only consistent with what we could see. And Webb has shown us more than we were ever meant to see. Beneath the chaos of debate, something beautiful began to happen. Theorists and observers, once divided by certainty, started to dream together again. Equations turned into questions. Questions turned into collaborations. A scientist in Tokyo modeled a universe filled with restless dark matter. A team in Chile tested how altered gravity would ripple through galactic halos. In Geneva, someone simulated what would happen if the early cosmos was denser, not in matter but in possibility. The screens glowed, the models broke, and then they began to sing. Because science, at its best, is not about being right. It's about building better ways to be wrong. Each hypothesis became a mirror, reflecting a different universe. One where physics isn't a cage, but a canvas. Maybe there are constants we haven't met yet, forces that appear only under the pressure of creation. Maybe the universe doesn't repeat itself perfectly because perfection was never the goal. It's alive, dynamic, adaptive, restless. If galaxies could bloom faster than expected, perhaps it's because the cosmos was impatient to become complex. The question isn't, why did it break the rules? It's, why did we believe there were rules at all? For centuries, we've treated the laws of physics like commandments carved in stone. But perhaps they are more like habits, strong, reliable, but capable of change. After all, the universe has evolved before. There was a time when atoms didn't exist, when light couldn't travel freely, when gravity hadn't yet sculpted the first horizon. If creation could evolve once, it can evolve again. Maybe these galaxies are proof that it already did. The universe may be the greatest experiment ever conducted, one that still hasn't finished running. We are part of that experiment, watching its variables unfold, measuring its revisions in the light of ancient stars. What Webb gave us wasn't contradiction. It was continuity, the reminder that knowledge is a moving target. Every time we think we've reached the end of understanding, the horizon pulls back, revealing more. The galaxies Webb found are not mistakes, they are invitations. Each one says, look deeper, think wider, dream louder. The crisis of cosmology isn't the end of science, it's its renewal. Because only when we admit that physics isn't complete can discovery truly begin. We are children of the unfinished universe, explorers of a language still being written. And maybe, one day, we'll realize that what we call laws are only the opening lines of a story that the cosmos is still learning to tell. Chapter 8. The Alternate Universes of Explanation. Science has always lived between two words, maybe and impossible. When James Webb revealed galaxies that defied both reason and timeline, physicists began to imagine what could fill the void between them. If the rules we know couldn't explain what we saw, perhaps there were other universes of explanation. Invisible domains where ideas could live freely until reality called them true or false. The first of these worlds was built around light itself. Some researchers proposed that the early cosmos might have hidden a different kind of star, something vast, primitive, and short-lived, called a black hole star. Imagine a star so enormous that its core collapses into a black hole while its outer layers are still burning. It feeds on its own fire, recycling matter through gravity and radiation in a loop that defies equilibrium. These monsters could shine 1,000 times brighter than ordinary suns and die within 1,000,000 years, leaving behind galaxies already seeded with supermassive black holes. To Webb's eyes, they would appear as the same brilliant red smudges we now call impossible. If such stars existed, then the first structures in the universe weren't built by patience, but by hunger. Gravity didn't sculpt them, it devoured them into being. Another possibility rose from deeper shadows, primordial black holes. These wouldn't come from stars at all, but from the earliest fluctuations of density right after the Big Bang. Tiny imperfections in that newborn chaos could have collapsed directly into black holes, each one a grain of gravity that later gathered gas, igniting the first galaxies around them. They were, in a sense, shortcuts, the universe's way of skipping steps in its own evolution. If true, then every galaxy Webb discovered might have been born around a heart of darkness older than the stars themselves. That idea reframed everything. Black holes weren't the graveyards of light. They were its midwives. Other minds proposed something gentler, the Sleeping Beauties. These galaxies, they argued, might have formed fast, burned bright, then gone silent, their stars fading before the cosmic background had even cooled. What Webb sees could be ghosts, after images of systems that lived quickly and died quietly, leaving behind a fossil record written in infrared. In that case, the universe might have always been efficient, not chaotic, building, burning, and resting in waves like breath. It's a peaceful vision, one where creation and extinction share the same pulse. But not everyone sought peace. A bolder camp suggested that what we're seeing isn't just about galaxies. It's about perception. Maybe the light Webb reads has been bent not once, but many times, by webs of gravity so complex that our instruments mistake echoes for origins. According to this view, the universe could be laced with cosmic mirages, overlapping lenses of space-time that duplicate and distort ancient light, making distant galaxies appear closer and older than they are. If that's true, then some of those 300 giants might be illusions, while reflections of fewer, nearer sources. Reality, as always, could be trickier than truth. Yet even that explanation felt incomplete, because illusions require design. For a lens to exist, matter must already have gathered, and if matter gathered so soon, the paradox only moved one step deeper. So scientists began to think beyond matter entirely. What if the early universe was saturated with fields, invisible fabrics of potential energy that fluctuated violently in its first seconds? These fields could have spawned temporary regions where the rules of gravity and pressure differed slightly. Small bubbles of alternate physics. Inside those bubbles, stars and galaxies might have formed faster, brighter, more violently, then merged back into the larger cosmos, leaving behind scars we now mistake for ancient light. Each bubble was, in effect, a miniature universe, governed by its own version of reality. And if that's true, then the Webb telescope is not just a window, it's a witness to other laws of nature that flickered into existence and vanished before we were born. Somewhere in this expanding landscape of ideas, the line between science and myth began to blur again. The universe, it seemed, was not content with one story. It wanted all of them. Theories multiplied like galaxies, each spinning around the same gravitational center. The question of how creation began so quickly. Some researchers turned to quantum gravity, a realm where space-time itself foams and trembles. Others revisited ancient hypotheses long dismissed. Variable speed of light, evolving constants, exotic matter. Each proposal felt like standing on a different shore, watching the same sea from another angle. And perhaps that's the point. Maybe the truth isn't a single island of certainty, but an archipelago of possibilities. Each theory holds a piece of the map, but none can see the whole. The three red monsters stood at the center of this intellectual storm. Three galaxies so large they seemed to mock the rest, their combined mass approaching 200 billion suns. No model could build them in time. No algorithm could explain their existence without breaking something fundamental. They became symbols of defiance, reminders that the universe doesn't obey human deadlines. They shouldn't be there, one scientist said, and yet they are. That phrase echoed across papers, interviews, documentaries, half resignation, half awe. Because behind every model, every simulation, every theory lies a single admission: we don't know, not yet. And maybe that's the beauty of it. Every new explanation opens another horizon, and beyond that horizon waits another question. The alternate universes of explanation are not fantasies, they are rehearsals for reality. Each one teaches us to think differently, to see that science is not about narrowing truth, but about widening understanding. One day, we may discover which of these worlds, if any, is real. But even if none of them are, they will have done their work. They will have reminded us that the greatest discoveries are not found in certainty, but in courage. The courage to imagine that the impossible is just the universe waiting to be understood another way. Chapter 9. The Cosmic Paradox. The deeper we look, the less we understand, and yet the more we feel. That is the paradox at the heart of the cosmos. Knowledge expands, certainty contracts. The galaxies Webb revealed are not just distant, they are contradictions written in light. Each one obeys the equations of physics perfectly, and yet their existence defies those very equations. The universe, it seems, is fluent in irony. For centuries, we believed that understanding would bring order, that knowledge was the antidote to mystery. But Webb has shown us the opposite. The closer we come to truth, the more the boundaries blur between comprehension and awe. What if the universe was never meant to be solved, only experienced? What if the questions are not mistakes, but messages? Perhaps the paradox is not out there among the stars. Perhaps it lives within us. the only species that can measure eternity and still feel small. Every paradox begins as dissonance. The mind wants the universe to make sense. The heart only wants it to mean something. Between them, wonder is born. The scientists who stare at Webb's data live in that tension. They calculate and doubt. They simulate and fail. And yet, they keep looking. Because beneath the frustration lies reverence, the recognition that the cosmos doesn't need to answer us to be magnificent. Each new image, each unexpected result, is a reminder that reality is not a closed equation, but a living process. The laws of physics are not commandments, but conversations. And sometimes the universe speaks in riddles. In those riddles, contradiction becomes beauty. Think of those ancient galaxies, massive yet young, bright yet shrouded, impossible yet real. They are the embodiment of coexistence, creation and chaos intertwined. It's as if the universe is both composer and improviser, writing a symphony where discord is part of the harmony. To human eyes, that feels wrong. To the cosmos, it's simply music. We want beginnings to be clean, stories to have structure, and causes to precede effects. But the universe might not care for such order. Perhaps creation and destruction were never opposites. Perhaps they were twins, born in the same breath, forever chasing each other through time. The galaxies Webb found are evidence of that dance. They are the places where order learned to coexist with disorder, where gravity's precision met quantum chaos and called it beautiful. Every contradiction they carry is a kind of truth we're not yet wise enough to decode. And maybe that's the point. The paradox doesn't exist to confuse us. It exists to humble us. Because humility is the only state in which discovery can survive. We look into the abyss and see ourselves reflected not as masters of knowledge, but as participants in mystery. To know that we cannot know is the highest form of understanding. Still, there's a quiet fear that follows that thought. If the universe is stranger than our laws, then where do we belong? If meaning is not written in its structure, must we invent it ourselves? The answer, perhaps, lies in the act of searching. Every telescope, every theory, every sleepless night spent chasing light from ancient stars. All of it is a declaration that curiosity itself is sacred. We search not because we expect answers, but because seeking is what makes us alive. That is the human paradox. Fragile creatures daring to study infinity. We build mirrors of gold and math to look backward in time, knowing full well that time will never look back at us. And yet, when Webb captures a photon that left its home 13 billion years ago, that photon becomes ours. We are part of its journey now. In that exchange, that brief union of observation and existence, lies the purest meaning imaginable. The cosmos doesn't have to explain itself. It only has to be witnessed. The paradox, then, is not a flaw in the universe. It is its poetry. It's what makes a silent sky feel alive. What turns equations into art. What transforms data into wonder. Every law of physics carries within it the seed of its own contradiction. A reminder that perfection is sterile and only uncertainty can grow. The more we learn, the more impossible things we discover, and still the story continues. The galaxies Webb found will one day fade, the telescope will fall silent. Our civilization, too, will pass. But the paradox will remain. Light traveling endlessly through space, carrying with it the memory of those who dared to ask why. Perhaps that is the universe's greatest achievement. Not stars or galaxies or gravity, but consciousness. The ability of matter to question its own existence. In us, the cosmos becomes self-aware, and through us, it learns to wonder. When we speak of paradox, we are really speaking of that awareness, of life asking the question that no equation can answer. Why is there something instead of nothing? The galaxies don't respond, yet their silence feels like an answer. Because in that silence, we hear the echo of our own longing. The paradox of the cosmos is not that it defies logic, but that it includes us, creatures made of stardust, dreaming of understanding the stars. The more we try to define it, the more it reminds us that we are part of what we study. We are not outside observers. We are reflections within the mirror of creation. Every photon Webb catches is a letter in that mirror's language, spelling a story that will never end. We thought we were mapping the universe. In truth, it was mapping us. Chapter 10. The Mirror of Time. Every telescope is a confession. We build them because we want to see ourselves from the outside, to step beyond the boundaries of our brief existence and watch eternity unfold. The James Webb Space Telescope is the grandest confession of all. A mirror not aimed at the future, but at the beginning. A golden eye turned backward through time. Each of its 18 petals holds a fragment of our desire to remember where we came from. When Webb looks into the void, it is not looking at distance. It is looking at memory made visible. Every photon it captures began its journey billions of years ago, carrying with it the handwriting of creation. These are not just particles of light. They are messages written before there were readers, waiting across cosmic silence for someone to listen. And when that light finally touches our detectors, it completes the longest conversation in history. The universe spoke, and we answered. But what does it mean to see so far that you begin to see yourself? The galaxies Webb revealed are not only the past, they are the blueprint of the present, the ancestors of every atom in our blood. The carbon in your breath, the iron in your blood, the calcium in your bones, all of it once burned in stars that lived and died before Earth had oceans. To look into that ancient fire is to look into your own reflection. That is the mirror of time, not glass or gold, but awareness itself. Through Webb, humanity has done what no species before it could. We have turned our curiosity into a bridge across ages. When we gaze upon those galaxies, we are not spectators. We are participants in a cycle of remembering. The light that left them now defines us. We become the continuation of their story. Every discovery Webb makes is both revelation and return, a reminder that the universe does not move away from us, but through us. Our instruments do not just extend our sight, they extend our identity. The more we learn about the beginning, the more we understand the present moment, fragile, luminous, temporary. The mirror of time shows us that creation never stopped. The Big Bang is not behind us, it is beneath us, within us, expanding still. Each thought, each heartbeat, Each act of curiosity ripples outward into that same infinite canvas. When you look at the night sky, you are seeing the past illuminated. When the sky looks back, it sees its own reflection in your eyes. Somewhere in that exchange, meaning is born. Perhaps that is the true purpose of all this, not to master the cosmos, but to be mastered by it, not to decode its secrets, but to recognize its reflection within ourselves. We build telescopes as extensions of longing, not arrogance. Every mirror we launch into the dark is another way of saying, we are still listening. The universe does not answer in words. It answers in light, slow, patient, honest. We turn that light into knowledge, and that knowledge into wonder. And in doing so, we close a circle 13 billion years wide. Webb is more than metal and mathematics. It is a monument to patience, to imagination, to the fragile brilliance of those who dare to look back. It reminds us that even in a cosmos ruled by entropy, something within us resists decay, the will to understand. When we peer into the mirror of time, we are not seeking certainty. We are seeking connection. We are searching for the faint echo that says we belong. Maybe that's what the galaxies were trying to tell us all along, that the universe was never distant, only waiting to be seen clearly. And maybe, when we finally understand that, we'll realize that every journey into the dark has always been a journey home. The light we see from those first galaxies began its voyage before there were eyes to see, before names, before thought. It crossed billions of years of silence just to arrive here, in this moment, in your hearing, in your heart. And now, for the first time, it belongs to someone. It belongs to us. That is the miracle. That something born in the dawn of time can find its way to the twilight of human thought and still speak clearly. We are the last link in a chain that began with fire and will end with understanding. The telescope may look outward, but what it truly reveals is inward. The courage to wonder, the patience to wait, the grace to be small beneath something infinite. The story of the impossible galaxies is not about data or distance. It is about what happens when curiosity outlives fear, when humanity looks into the dark and does not flinch, when we remember that to search the universe is to remember who we are. Because in the end, the greatest discovery is not what lies beyond the stars. It's that the stars have always been within us.